What is ETL? You've probably heard these three letters before, but what does ETL really mean? And what does it mean for data pipelines? Interested? Let's get started. ETL stands for extract, transform, and load. And it's the most common, traditional process followed inside a data pipeline. If data pipelines describe the whole process for getting data from a raw state into a consumable one, ETL is like the heart of this process, and it has three parts. Let's look at each of them in more detail. The first stage is extraction. The extraction phase describes the process of identifying the source system that contains the raw data that you want to load into the data pipeline. Typically, this involves copying raw data from one system to another, usually from the system that generates the data in real time to one that can store a copy of it for analysis. This process can be complex because moving data from one system to another sometimes requires differences in the underlying system to be ironed out. The next stage is transformation. This is the heart of the ETL process and the one where the most work is accomplished. Data from multiple source systems usually comes with variations. This is expected because no two systems will usually store data in exactly the same way. For example, imagine a company includes offices in different parts of the world, and they want to compare customer data. Each time a customer creates a transaction, a date is recorded, but different areas of the world record dates differently. Some might include day, month, year, and others might include month, day, year. Others may have other variations. When you bring these two systems together, the data is in a different structure, and it makes it useless for comparison. The two systems simply don't work together without some work being accomplished. To make it useful, you need to transform the structure of one of the data sets and instruct the data pipeline to adopt a common standard. This will involve writing conditional logic, sometimes using SQL and sometimes using a language like Python or Scala to search for all instances or variations and normalize the data set. The date example might be a common relatable variation in structure, but there are potentially many hundreds of other structural differences that could arise. Identifying these and determining the logic needed to resolve the discrepancy is one of the most important parts of data engineering. Additionally, some datasets might also include entries where data is either missing or incomplete. These also have to be identified and appropriate actions taken to fix the issue. For instance, one system might record blank entries as null, while others might include blank entries as 0. One dataset might include numbers of a particular data type as an integer, while another might include similar data types as a string. These differences add up, and getting a clean dataset involves creating the necessary transformations to allow for standard, reliable datasets. The final step of the ETL process involves loading. Once the transformations are complete, the new transformed dataset is loaded into a new system. From there, it can be queried or consumed using a BI tool or other system. Each step of this process is rationally planned out to create reproducible, predictable results. So in the end, if you think of a data pipeline as the process of moving data from a raw, unusable state to a processed, consumable one, ETL is the process within a process that gets the job done and makes sure that all of the data sets are on the same page using the same common vocabulary. In the end, it's these processes that make data usable and allow for the business decisions built on top of them.